Hey guys, and welcome to a new video in this computer vision tutorial. In this video here, we're going to talk about pose estimation. So first of all, we're just going to talk about some different kind of stuff that we're going to do beforehand before we can do our actual pose estimation. So we're going to talk about some different kind of like camera calibration, and we're going to use the extrinsic parameters of the camera to actually like do these 3D to 2D projections in our camera and do this pose estimation here of objects in our image. But first of all, remember to join the Discord server. I'll link to it down in the description here, and you can come join the channel here, chat with us about computer vision, deep learning, artificial intelligence, and so on. And you can now also be a member of the channel here if you want to support the channel even more than you're currently doing, and everything will go to make better and more quality content here on the channel. So first of all, we're going to talk a bit about camera calibration, as we've already been over in previous videos and throughout this tutorial here, where we're going to use camera calibration to actually like get the intrinsic and extrinsic parameters in our camera. Because when we're going to do pose estimation of an object in the camera frame, then we're actually like going to use the extrinsic parameters that we'll get from camera calibration. I'll just shortly go over what camera calibration is, and then later at the code, I'll show you the code for camera calibration. We'll just run the Python script that we already went over in one of the previous tutorials in this video here. So if you want to know like how we can calibrate a camera and what the code does line for line, make sure to check that video out as well. It's really cool that we can actually like use this camera calibration for a lot of different kind of stuff within computer vision. But in this video here, we're just going to talk about like what is camera calibration. We're going to run the camera calibration script, and then we're going to use those parameters to actually like do pose estimation here at the end of the video. So first of all here, when we're going to do camera calibration, we're going to use multiple images of a known object. So in this case here, we're going to calibrate our camera with this chessboard here, as you can see on the images to the right. Then we have to have different kind of positions of that known object in multiple images, where the chessboard here, in this case, it is both rotated around in the frame. We're translating around here on the table, and we also tilt it as well for the known different kind of objects here. So we actually like have multiple images where our chessboard is actually like rotated, translated, and tilted around in the multiple images. So we use that for our camera calibration. And when we just pass these different kind of images to our actual like Python script, then we compute the camera matrix. We get the distortion parameters, so we can actually like undistort our image. So we can see here to the right that like the edges of the table here is actually like really curved, and down at the bottom we can see the undistorted image, where we can see we now have a straight line to the left of like the left edge here of the table. And then we also get the rotation and translation vectors, or like the rotation matrix, which is the extrinsic parameters in our camera that we get from camera calibration. And these are the parameters that we're going to use to do the actual pose estimation of an object. So in this video here, we're just going to do a pose estimation of this chessboard here. So we want to know like how it is rotated and translated around in the actual image frame here. So we use those parameters to actually like do the pose estimation, or like the 3D pose estimation. But in this case here, we only have a monocular camera, so we'll just say like the depth is equal to 0, which is the C coordinate in the XYZ world coordinate system. We can also use camera calibration to remove distortion, as I just went over here. So let's now talk about pose estimation here and what we're going to do to actually like do this pose estimation in OpenCV. So first of all, we need to find the rotation and the translation vectors from our camera calibration, and we can use the built-in function in OpenCV solvePnP, which actually like just find these different kind of like rotation and translation vectors for specific object points in our image. So we can actually like project those points down to the image plane, like the 3D point to the image plane later on. So we give it the object points here, which is just the points of the chessboard here in our image, and we also give it the corners. So the corners in this case here is the actual like corners of the chessboards that we found with the camera calibration as well. But then we give it the camera matrix and also this distortion parameters, and then we can just use this solvePnP here, and we will get the rotation vectors and the translation vector here as well, which we can actually like pass to the next function here that we're going to use, which is actually like the function that project the 3D points to the image plane. So we can actually like have this relation, and we can describe like how an object in our image frame is actually like rotated, or like how it is rotated with respect to the camera frame. So we actually like having the camera frame, and then we also have the world coordinate frame, and then we actually like have the extrinsic parameters. Then we can relate how the camera frame is with respect to the world coordinate system. So the next function here that we're going to use is this project points here, where we just give it some axes that we talked about in the camera calibration video. And then we have our rotation vectors, our translation vectors, our camera matrix, and our distortion parameters. And then we can actually like just give it to this function here, project points. It will project the 3D points to our actual image plane, so we can do this this box here later on in the code. And then we just get the image points back here, which we're going to use later on, as I'm going to show you in the code. So down here at the bottom, we can actually like see the results of what we're going to do when we're doing this post estimation here in OpenCV with Python and in this video here. So we can see here to the left that we can actually like have this chessboard here where we tilt it around. So we're just going to use the same images as we had in our camera calibration. So our chessboard is both rotated around, it's tilted around, and also translated around. So we can see here when we're trying to estimate the pose of this chessboard here to the left, we get this kind of like top view here of our chessboard, because it kind of looks like that with our camera we're just looking directly into our chessboard, and it's not really tilted that much, or like at least the object, like we're trying to describe how the object is actually like rotated or like tilted with respect to our camera system. So to the right here, we actually like see another example, and I'm going to show you like how we can actually like do this in code here as well. And we're going to see some more examples at the end of the video here. But to the right here, we can see that we have this box here where our chessboard is actually like now it has another pose where it's kind of like rotated or like tilted away from the camera. So we can actually see we have some different kind of like depth here, even though we're only working with two-dimensional or like the image plane here, where we don't have any information about the depth, but we can still try to estimate the pose of the actual object in our image frame. And then if we had like, for example, a stereo vision setup, we can actually like make this 3D point estimation by using kind of like same method here. But in this example here, we're just going to describe how this pose estimation here, or like how the pose is of an object with respect to the camera that we're seeing this object from. So I'll just show you a look here at the documentation of this solvePnP function or like method here that is built into OpenCV. So if we look here, we can actually see that we need to pass in the object points, the image point, and the camera matrix, and the distortion coefficients here, as well as I just showed you in the slides. But down here, we can actually like get a short description of what this function here does, and it also shows an example of how it does it. So here we can see that this function here, it finds an object pose, which is the example that we're going to do in this video here, where we have this chessboard where we're going to find the pose of that object or that chessboard from having these 3D to 2D point correspondence when we're trying to relate how the 3D points in the world coordinate system is to the two-dimensional image frame or like image plane. So this function here returns the rotation and the translation vectors that transforms a 3D point expressed in the object coordinate frame to the camera coordinate frame using different methods. And then we can like specify what different kind of methods that we want to use. But what it describes here is basically just what we went over here in the slides, where we can like actually like relate the 3D points to the image plane and so on. And then if we scroll down here a bit more, we can see the different kind of parameters that it takes as input parameters, and also the output rotation vector and the output translation vector that we're going to use in the next function, where we had this 3D project function. So if we go down here at the bottom, we can actually like see an example here of the function here estimates the object pose given a set of object points here for their corresponding image projections, as well as the camera intrinsic parameters and the distortion coefficients. And we can see the figure here below. More precisely, the x-axis of the camera frame is pointing to the right, the y-axis is downward, and the z-axis is forward. So here we can actually see an example of what this function here does. So we have this world coordinate system here where we have different kind of points here in the world coordinate system, and these are the points of our actual object that we're going to try to estimate the pose of. And then we have our camera coordinate system here, and then we actually like have our image plane here. And then by using the extrinsic parameters or like the rotation and the translation vectors from doing this camera calibration and this solvePnP here, then we can actually like relate how these world coordinate points here of our object is related to the camera system here, or like the image plane, so we can actually like display the object pose, or like in this case here the chessboard pose, as I showed you in the slides as well, where we have this box where we're trying to estimate the pose of that chessboard by showing this box here. So at the bottom of the documentation here for this function, we can just see these different kind of matrices here that we're going to use to actually like have this rotation and translation, and how we can relate the 2D points to the 3D points or the other way around. So we can see here that we have the points here in our image plane, and over here we have the points in our world coordinate system, and then we have like a vector here that describes the projection from 3D world coordinates to actually like 2D or like to coordinates in our image plane. And then we can see that we have some different kind of matrices here inside. So the first matrix here is our camera's intrinsic parameters. So we have the focal length in the XY direction and in the Y direction, and then we also have the optical center here of the camera. Then here we just have an identity matrix. Then we have the extrinsic parameters here of our camera. So we have the rotation matrix here, and then we have our translation vector over here to the right. And then at the end here, we actually like have the world coordinates of the object in our world coordinate system. And then at the bottom here, we just have zeros and ones here, which is because we're using homogeneous coordinates when we're going to use this. And down here at the bottom, we can just see here that the estimated pose is thus the rotation, or like the rvec that we're going to use in the code, and the translation, which is the tvec. The vectors that allow transforming a 3D point expressed in the world frame into the camera frame. So this is just how we're projecting 3D world coordinates down to the 2D image plane, which we're going to use when we're going to do this post estimation here of our chessboard in code. So first of all, we're going to calibrate our cameras because we need the intrinsic parameters, and we also need the distortion parameters, so we can actually like do this post estimation and get a more accurate result. So first of all here, I'm just going to run this Python script here of the camera calibration. And then at the end of the file here, we're actually like just going to save the different kind of parameters that we actually like have or like get out from this camera calibration function here. So if you want to know like what these different kind of functions here does and line by line, then make sure to check the video out where I go over this code here in the camera calibration tutorial. But in this video here, we're just going to run the Python script. Then we'll go into another Python script for our post estimation. We're going to use these parameters here from the camera calibration, and then we're going to use the functions that I just showed you in the slides to actually like do the post estimation of our chessboard in the image frame. So first of all here, we're just going to run this script here. So if I hit Control B here, it will now run the Python script here. We load in the images after 1 second here. It will find these corners in the chessboard. We're actually like doing the camera calibration, and we can see here at the end, our camera calibration has now ended. We get the camera intrinsic parameters here. So we have the focal length here in the first here, and the second here is the focal length in the X and the Y direction. And then over here to the right, we just have the optical center of our camera. We also get the distortion parameters. So these are the two. So this is the matrix, and this is the vector that we're actually going to use to solve this PNP function that I showed you in the slides as well. Then we now actually have our undistorted images here. So if you look at the first image here that we're going to calibrate, we can see that we have this curvy line here over here to the left, or like the curvy edge here to the left at the table. And then if we go down here to the undistorted image, we can now see that we have actually like removed that curve, or that this fisheye effect here on our camera lens. So we can see the result here of the camera calibration that we have done. And then we're going to use these images here now to actually like do the post estimation of the chessboard here in our image frame. So if we go into another Python script here for actual like post estimation, then first of all here, we're going to load in the camera parameters that we just found in the camera calibration Python script here. So first of all, we're just going to load in the camera matrix that we're going to use and the distortion parameters. The rvecs and tvecs here, we're going to find that with solvePnP, so we don't really need that. So we're just going to use this camera matrix here and the distortion parameters. Then we can go down here and create two functions here where we can just like draw a coordinate system, or we can actually like draw the boxes that I showed you in the slides. So these are just the lines that we're going to draw some lines here at the different kind of like image point, and also the corners that we're going to pass to this function here from the actual like when we're actually like finding the corners and the image points with these functions that we're going to run later on. So this is just functions to actually like draw something. So we're just going to draw the lines here, or in this case down here, we're going to draw some contours. So we can actually like draw these boxes here around our object to try to estimate or like visualize the pose that we have estimated of our chessboard. So down here, we can set up a criteria here, and we also need these object points here and the axis. So these are just the default setup things here that we need to pass to these different kind of functions, or like the built-in functions. So if you want to know more about details like why we need these different kind of stuff, make sure to check the camera calibration tutorial or video out as well, because we're going in depth with what the object points is, and also why we need this axis variable here that we're going to pass to the functions later on. We also have a termination criteria up here, which we're going to use in some of the built-in functions. So down here, we can actually like just have this for loop here running through all our undistorted images. So in this example here, we now have 5 undistorted images over here, which is the images that we did the camera calibration on as well. So now when we have these different kind of undistorted images, then we can use those to estimate the object pose, or like the pose of our chessboard in the image frame. So first of all here, we're just going to load in an image one by one. So we just go over one example here in the code, and then we do the exact same thing for all the 5 images that we have undistorted with our camera calibration. So first of all, we're going to load in the image. So we now have the image stored in this variable im here. Then first of all, we're going to grayscale the image. So we're just operating with grayscale images. So we don't have to operate with free channels because we're just going to estimate the pose, and we don't really need information about the colors of that object or in the image. So down here, we're going to find the chessboard coordinates as we did in the actual camera calibration tutorial. So we're just going to pass this grayscale image. We're going to pass in the chessboard size. So we actually find the number of coordinates here in the chessboard, and then we return the coordinates here that we're going to pass into this coordinate subpixel. So we actually find coordinates in subpixels, so we get a more accurate result of where the actual coordinates is in our chessboard. And then these coordinates too here is the actual coordinates that we're going to pass to this solvePnP. So we have these points here in our world coordinate system, and then we're going to solve for those. So we actually have both our object points and our coordinates here for our chessboard, which is the points that we're going to pass into the solvePnP. And then this solvePnP here will just find the rotation and the translation vectors by passing the camera matrix and the distortion parameters, or like this distortion vector here as well. And this is the intrinsic parameters of our camera in this MTX variable here, which is a matrix. Then we can go down here and use this function as I showed you in the slides, where we're going to project the points here, or like the 3D points from our world coordinate system to our image plane, and then we can actually relate how those are to the actual camera or our image plane. So we're going to use this project point function here. We're going to pass in this axis boxes here, or just the axis, depending on if you want to draw the coordinate system or if you want to draw the boxes as well. We're going to pass the rvex and the tvex here that we found from this solvePnP function up here. We're going to pass in the intrinsic parameters and also distortion here as well. Then down here, we're just going to draw the actual boxes or the coordinate system here on the object that we're going to estimate the pose on. And then when we have done that, we're just going down here and we want to wait here. If we hit the key, if we hit S here on our keyboard, we will save the image here, or we will save an image here of the pose that we estimated off the chessboard in the image. Then we go down here and we just destroy all the windows after we've been through all the images here in our for loop. So let's now run the program here and draw the coordinate system here of our object pose. So if I run this program here, I hit Control B here again, and we can see that we get up the first image here. So we load in the first image here from our undistorted images up here, which we did with our camera calibration. And then here we can see that we're actually estimating the pose of the object or the chessboard. In this example, we're looking at the chessboard from above, and it's not really tilted in the image frame. So we can see that we just get this nice coordinate system here, where we have the z-axis going up here in the red, and then we have the x and y here, which is blue and green. Then if I hit another key here, we will go to the next image, do the same different kind of processing techniques that we just went over line by line. So we're going to run this for loop or these methods here through 5 times, because we have undistorted 5 images. Then we go to the next image here. We can see that now it is a bit more tilted. We have translated the chessboard over here to the left. We still get we're actually looking a bit more towards the left here, so we can see that we're not looking directly into the chessboard here now, because our camera is from this top view here of this table or the chessboard in this example. So we just take the next example here again. We're now translating our chessboard up here to the top. We take the next image. Now we can see that we're actually tilted our chessboard as we saw in the slides. So now we can actually see that we're actually estimating the pose here, or we're actually estimating this tilting of our chessboard in the image frame as well, even though we only have information about two dimensions here in our image plane. But because we're taking the 3D points and projecting them down to the image plane, we can actually do this pose estimation of an object. So the last image here is actually just another example where we have just tilted the chessboard here at another angle. So the other example here I want to show you is for the boxes here in this example. So we need to change this axis to the boxes, and then the drawer function down here, we also need to call that the drawer boxes. So we're actually drawing these boxes that I showed you in the slides instead of just the coordinate system. So if we run this program here again, we're just going to draw these boxes here instead of the coordinate system. And when we just hit another key, we'll just go to the next image, do the same processing as well. And we can see that we're now just drawing this box here, which is the post estimation of our object in our image frame. So this is a really nice and cool feature that we can actually use for a lot of different kind of things if we want to estimate how something is rotated, or like how some object is actually like posed in our image frame. So this can be used over a lot of different kind of things, like for example in industrial robots or stuff like that, with pick and place systems, and a lot of other different kind of cool features where a robot has to pick something up in a basket, for example, and place it at some other different kind of place with a correct orientation, or like at a correct pose. So that's it for this video here, guys, where we know how we can use camera calibration, post estimation, these different kind of like camera parameters, like the intrinsic and the extrinsic camera parameters, how we can use the different kind of information we have from 3D world coordinates, and how we can project them down to a 2D image plane, and how we can relate the pose from the actual like 3D points to the image plane, and doing this post estimation here. So thank you guys for watching this video here, and remember to hit the subscribe button, bell notification under the video here, and also like the video if you like the content and you want more in the future. It just really helps me and the YouTube channel out in a massive way. I'm currently also doing a deep learning tutorial where we're talking about like how we can solve different kind of computer vision tasks as well with deep learning, and we're going over the basic stuff. So if you're interested in that tutorial and how we can combine computer vision and deep learning, make sure to check that tutorial out. I'll link to it up here, or else I'll just see you in the next video, guys. Bye for now.